Hey guys, I wanted to just give you an option of listening kind of to the lecture that goes with these notes. We talked about types of bonds, and that was in the April 13th and 14th folders if you want to kind of review that. If you remember, there were the nonpolar covalent, polar covalent, and ionic bonds, and we did the analogy with the blanket being the electrons. So if two atoms are sharing the electrons equally, they're going to be, like, the analogy would be they'd share the blanket equally, and then if they're not sharing, that would be a nonpolar bond, covalent, and then polar covalent is they're sharing but not equally. So one of the atoms is going to pull the electrons more towards itself than the other. And then ionic is the extreme case of just taking, one of the atoms will take the electron from the other. So, which has everything to do with electronegativity. So we're gonna talk about electronegativity right now. If you remember, we covered this with when we did the periodic table. So on your periodic table, electronegativities are these bottom numbers. So like fluorine is 4.0, rubidium is 0.8. So these values, it's a scale from 0 to 4, 4 being the highest. So the ones that have the higher electronegativity, like this would be like fluorine, is going to be able to pull electrons towards itself. So electronegativity, the definition is it's the pull that an atom has for the electrons that are being shared in a bond. So ionic bonds, the electronegativity difference are going to be so big that they're not even going to share unevenly. One atom will just take the electrons away from the other. So example, like sodium chloride are, table salt. The sodium will give its electron to the chlorine, and then you get a positive sodium and a negative chloride ion. Here's a little analogy of an ionic. Hopefully, where is it? Let me start it over. So the bone would be representing the electrons, and one of the, the big dog gets both bones, and the little dog gives up its electrons. So nonpolar covalent, this is when the electronegativity values are really close to the same or equal. So they're going to pull on the electrons equally. So example would be chlorine bonded to chlorine. They're identical, so they're going to pull exactly the same. My little dog analogy here. So the electrons would be the bone, and they're sharing it nice and equal. Polar covalent is when they're gonna share it technically, but just not equally. So one of the atoms is gonna pull more strongly than the other. So in this example here, the chlorine has a higher electronegativity value than the hydrogen, and it's going to pull the electrons in the bond towards the chlorine, which results in this part of the atom being partially negative and this part being partially positive. It's not a full positive and negative like an ionic. And here's our little dog analogy. So the gray dog is pulling the electrons more closely to itself, which gives us that partial negative charge, and then that results in the other one being partially positive because now it doesn't have all the electrons around it. Its nucleus is kind of exposed. So like I said, the electronegativity values are on your periodic table. And then what we can do is we can figure out what kind of bond it is based on the numbers now. So we look at those electronegativity values and we can subtract them. And then if it's a difference of 0 to 0.4, then it's considered nonpolar covalent, which means they're sharing equally. If the difference between the electronegativities is 0.5 to 2, then they're sharing, but not equally. So that's a polar covalent. And then ionic is when they have a difference greater than 2.0. And that's where there won't be any sharing. It'll just be a transfer of electrons. So when you do have a polar bond, remember that one atom is going to pull on those electrons and become partially negative, and the other one is going to then be kind of exposed, its nucleus, and become partially positive. So we show that using these little Greek letters. These are lowercase delta. This is just a way of saying that it's partially, not completely positive, and partially negative. You'll also see that we use these dipole arrows, and the dipole arrow is going to point towards the one with the higher electronegativity and away from the one that is the lower electronegativity, which you can kind of see this is kind of like a positive. So you're pointing the arrow towards the one that's more electronegative because they're going to pull the electrons, and then the one that it's pulling away from is going to become partially positive. So an example of how you would use these is you'd actually draw the little Greek letter delta positive, delta negative, the negative over the one with the higher electronegativity. Or you can use this dipole arrow and you move that along. You kind of draw it parallel to the bond. So then you're just saying these electrons in the middle are getting pulled by the fluorine away from the hydrogen. So let's practice. So how do we do this? So if I want to know, well, what kind of bond is it then between carbon and hydrogen? What I want to do is find them on the periodic table. So carbon is 2.5, hydrogen is 2.1, and I just want to subtract them so that I get a positive number always. So it's really just the absolute value, or just always subtract so you get a positive. And it's 0.4. And that, remember from that other slide, 0.4 is essentially close enough to equal that we call it a nonpolar bond. Here's another example with carbon and chlorine. Again, carbon's 2.5, chlorine's 3.0. So when we subtract them, now we get 0.5. So now it's considered to be, a polar covalent bond. So they're sharing but not equally, and the chlorine is the one with the higher electronegativity, so the dipole arrow is going to point towards the chlorine away from the carbon. And then here's another example. Potassium's over here, chlorine's here. When I subtract those, I get 2.2. Now I'm in the greater than 2.0, which is an ionic. So now they're not sharing these electrons. The chlorine's going to take the electron, become negative, and the potassium's going to give it away and become positive. So here's one more example. Oxygen and chlorine, the difference between them is 0.5. So it is going to be a polar covalent bond. So you do want to draw the dipole pointing towards the oxygen because it has the higher electronegativity. I hope that helps, and let me know if you have any questions.